everyone, and thank you so much for joining us today. I am your host. My name is Shireen Benzayed. I'm Head of Innovation at Finastra. And we're welcoming you for this live meetup, which is one of a series. It's part of our Hack to the Future Global FinTech Hackathon. Hack to the Future is a fintech movement igniting a world of financial sustainability, inclusion, and empowerment. And today, we've actually entered the last week of the hackathon. So you've got till April 10 to register and submit your idea or project. Actually, building on the success of our previous hackathons, we've launched Hack to the Future 4 to redefine finance for good and to inspire the fintech space to be open by default to everyone. Now, this year, we aim to drive engagement beyond our global fintech ecosystem with three main themes that are open to all. The first one is sustainable and inclusive finance with everything ESG, environment, and financial inclusion. Second theme is embedded finance and banking as a service. And third theme is everything decentralized finance. And today, we'll be talking more about the third theme, so DeFi, and we will specifically focus on how to build a decentralized application. And with that, I'm really excited to introduce Adam Lieberman and Haylee Anderson, who will be joining me.
Hello, everybody. Nice to see everyone. My name is Adam Lieberman. I'm a distinguished engineer, head of AI and machine learning at Finastra.
Hey, everyone. My name is Haylee Anderson, and I'm a data scientist here on the innovation team.
Thank you. So with that, over to you guys, and let's get started building a dApp.
Let's do it. So I'm going to share my screen, and then let me know if you guys can see it when I start the presentation.
Yes,
I can see it.
Cool. So once again, welcome everybody. Thank you so much for joining us. Today, before we show you how to build a dApp in about 15 minutes, we're going to talk a little bit about the individual technology components that are behind dApps. And some of these we're actually going to use when Haylee gives us a demo. The first thing, which I'm sure a lot of people are either familiar with or have an account, is MetaMask. And what MetaMask is it's a browser extension that's really designated to making accessing Ethereum's dApp ecosystem easier. It serves as a wallet for holding ERC20 tokens, allowing users to access services built directly on the network via the wallet. So it's basically a cryptocurrency wallet to interact with the Ethereum blockchain. And we can access our Ethereum wallet through their mobile application or through an extension like Chrome, which helps us interact with these decentralized applications. The next thing is Truffle. So Truffle is a development environment testing framework, and it's an asset pipeline for blockchains that use the Ethereum virtual machine, or what we call the EVM. So basically, it's an ecosystem for dApp development. It helps us manage our smart contracts, automate the testing of the smart contracts, and then what's called migrating and actually deploying our smart contracts. So we can also kind of manage the network artifacts and do a lot more. So Truffle is definitely an integral component of our dApp development. The next thing is Ganache. So what Ganache is it's pretty much a personal local blockchain that we can spin up for rapid development of our Ethereum dApps. It allows us to develop, deploy, and really test our dApps in a safe manner before we deploy them to an actual blockchain. And basically what we do is we love to use it to test our smart contracts locally on this personal blockchain. As well, Ganache is a part of that Truffle ecosystem that we saw on the last slide. The next thing is Solidity. So Solidity is a programming language for developing smart contracts that actually run on Ethereum. It's object-oriented, and it's a pretty high-level language. But if you do want to learn, the basics, there is a really great free resource called Crypto Zombies that will help you understand pretty much the entirety of the language in a fun kind of gamified way. but Solidity is what we use to actually program our smart contracts. The next thing you'll come across is Web3. And Web3 has JavaScript and Python client libraries for interacting with Ethereum. It allows us to execute our smart contract functions. We can listen to events. We can read and write data from the smart contracts and much more, all from the front end of the application that we're developing. For example, we might have a button click that triggers, a function in a smart contract, and web3.js or web3.py can help us actually hit that. The next thing you might come across when you're developing a dApp, kind of as a POC, is Flask. And what Flask is it's a web framework. It's really a Python module that lets you develop web applications kind of in an easier manner. It's very, very lightweight. It's super easy to learn, and it can help us create endpoints for an application to interact with it. So pretty much it makes it very easy to build web apps, and it has kind of the familiar Python bones to it. So Flask is something you might come across or use when you're building a dApp or a web application. And finally, there's 3 frameworks for building web applications that probably every front-end developer has heard about. They are React, Vue, and Angular. So React is a UI library. Angular is a fully fledged, front-end framework. And Vue.js is a progressive framework. And by progressive, I mean that, if you have an existing server-side app, you can plug Vue into just one part of that application. You can make changes if you wish with their core libraries. And Angular, React, and Vue can be used kind of almost interchangeably to build front-end applications, but they're not 100% the same. But each framework is component-based and allows the rapid creation of UI features. So these are 3 very, very popular choices that you can use for the front end of your application. So putting a lot of these together, we can build a dApp. And what I'm going to do now is hand it over to Haylee to take you through some rapid development on building a dApp.
All right, let me start sharing my screen. Let me know when you can see it.
Yeah, we can see it now.
Good. Okay, so for our first step, we're going to create a decentralized marketplace website for startup companies. And this will all be powered by our smart contract on the blockchain. So this is what our app's going to look like. So basically, it will let us create a startup idea or startup with a description and the funding amount that we need in order to for the startup. So this will be in Ethereum. And then it's going to list all the startup ideas in a table, including the wallet address of the owner and the status of the startup, which will allow for anyone to fund the idea, which will then create a transaction within your MetaMask wallet. So let's go in with the perspective of a startup owner. In my MetaMask account. Sometimes it takes a while to connect. There you go. Okay, so now that we're in the owner's wallet, we can start a startup for like maybe a bookkeeper. And then let's ask for Ethereum. Then we add the startup. We'll have a transaction in our MetaMask pop up. And this is where we're going to have to confirm the gas fees, because anytime you're dealing with transactions on the Ethereum network, you're going to have to pay a certain amount of gas. Oh. Sorry, everything just closed on my screen for some reason.
While Haley's pulling it back up, Delvin, thank you. Yes, we will post the slides after this meeting, and you can check our Discord. We'll have a PDF of them for you there.
Sorry about that. Okay, so and then you can see once it loads through, you can see that our startup description idea is here listed. And then if you switch to the perspective of a funder account on our MetaMask wallet, funder account, and then you can fund the startup, and then you'll have another transaction. And then once I click the transaction, it will give me a transaction for Ethereum that was requested from the owner. Oh, sorry, I'm having some internet trouble. Sorry, I'm having some internet trouble. Okay, so there we go. And then we have the transaction for the 3 or 4 Ethereum that the owner requested. And then once we confirm, it should send the 4 Ethereum to the owner's account. And then you should have 4 less Ethereum in the funder's account once it goes through. And there we go. Then once I pop this up, you can see the transaction. But while we're waiting that to load, let's go into, let's see how it's done. So basically, the first thing you want to do is install some dependencies. The dependencies you need is Truffle. Is Truffle. Then you also need to install the Ganache GUI, which is allows us to deploy our smart contracts. And then you need to install the MetaMask extension. And then most importantly, you need to install the Web3.js, which is the library that you need to interact with the local Ethereum node. So now that the tools are set up, we're going to set up our project environment. So we want to set up our project folders. And within these folders, we want to, sorry. There we go. We want to set up a React environment with this command create React app, which is basically a boilerplate of all the basic React applications that we're going to need. And then we also want to initialize a Truffle project using this command Truffle init. It also gives us a boilerplate of directories for our smart contract development. Sorry. So now opening up our project directory, we should have a structure looking like this. Within our directories, you can see we have a migrations folder, which basically allows us to migrate and deploy our smart contracts to the Ethereum network. The files are ordered, which basically tells Truffle which order to run them in. And then we also have a source folder, which contains a directory that holds smart contract builds. And these are JSON files, so they're basically descriptions of how our contract behaves. And then we also have our components folder, which basically holds our JavaScript files for our front-end development, and our contract folder where our smart contract will be stored. And then notice we have a migrations file. This file keeps track of all our migrations. And then we also have a truffle config file. This is all the configurations of our truffle project that we will help us connect to our project to the blockchain network. So now first thing, we want to create a new file under our contracts. This is a new smart contract. So this is what it's going to be looking like. So for our smart contract, we want to store the address of whoever is calling the smart contract. And then we also want to create a state variable, and we'll call this startup account. This basically keeps track of all the number of startups that are going to be created on the blockchain. And then a mapping function, which basically stores all our attributes and allows us to look up the ID of each startup. And then we also have a struct. So in Solidity, this allows us to create our own data structures. So this contains like attributes of the startup and then what the user will need. So this includes like the address of the owner, the ID of the startup, the description of the startup, the amount, and whether or not if it's active. And then we have two main functions that our startup will do. One is for the owner to create a startup, and the other is for the funder to send funding to the owner of the startup, which we will declare this function as payable. This will ensure that the function can send and receive Ether within both functions we have. And then we also have some required functions, which is basically for checking conditions. So after our smart contract is set up, we have to set up our truffle development environment. So in our startup repository, we're going to have to run the commands truffle migrate. So basically, the migrate command will create like these ABIS file structures, and this will help us enable to push the smart contract to the Ethereum blockchain. So now that we are finished with our smart contract, let's connect our front end code to be able to interact with our smart contract. So we will have a app.js file and a main.js file. So in our app.js file, we will import, we want to connect to the blockchain, so we'll import the Web3 library. So this is going to be at the top of the file, as well as importing the build of our smart contract. Next, for the functions that we will implement a component called component will mount. So this is basically used to implement server-side logic, but in this case, we're going to use it. In this case, we're going to use it as a load Web3 function that will detect if you have a connection to the Ethereum network. And then we also have a load blockchain data function, which helps us load all the blockchain data. And this includes like accounts and network data in this function. And then it will also detect if you have a connection to your smart contract. And then we want to create some functions for requesting and funding our startup. And then for our render function, we will render out our components out onto our application page. And then for our main file, this is where we're going to pass all our components and functions, which creates the structure of our UI. And then after all this is complete, you're going to start your development file. We're going to start our development server. This is going to open up your web application into your browser, like so. And then once you do that, you want to set up your blockchain instance with Ganache. So opening Ganache, you want to create a new workspace. I called it startup dApp. And then you want to import your truffle.js folder. And then make sure, and then once you do that, you want to make sure that your RPC server and your network ID matches the one in your truffle config file. And then now opening your MetaMask account, you want to make sure that the new network that you're making is the same RPC server as the one in Ganache. And then from there, you're able to import all these accounts, like the ones listed in Ganache, and to try out your application. And so, yep, that's basically how it's done. And that is how we created our first dApp.
Awesome. Thank you so much, Haylee. If anybody has any questions, feel free to pop them in the comments and we'll answer them.
Yeah, thank you so much, both. I do actually have a question that we get quite often from the audience and the hackathon participants. Will the code be available for the hackers?
Yes, we will have a public GitHub repository that you can access all the code from this project, and we will be available on Discord if you have any additional questions around it or you want us to go through it again with you.
Cool, thank you. And for everyone watching, you can get more information about the hackathon, register on fintech.devpost.com. And from there, you should be able to get access to Discord and access any other resources that the team are sharing with the hackers here. Given we don't have any more questions, I would like to thank you both very much. I think it was a short and very insightful session. Thank you so much for that. I think both of you are also available on Discord. So if anyone is watching the session later on, if you have any questions, feel free to reach out to Haylee and Adam and all of us as we're on Discord. So thank you so much. Thanks a lot, everyone watching us. And yeah, see you soon on Discord and on fintech.devpost.com.
Thank you all.
Thank you, everyone.
Bye.